How are you, my people? I greet you now once again. This one now, my brother man, Dr. AMG. As usual, I don't come so that we could learn small mathematics they go. Now, as we dey talk, the series wey we get, wey we dey use dey go small small, na the code, na the name, we dey call am MTH102. And when this one don come, the main thing wey we say we wan learn inside this code na calculus. The main thing wey we wan learn inside this thing na calculus. Now, when we don write the calculus, we know say we dey learn other small small topic dem wey dey inside. Now today na which topic we wan talk about? The thing wey we go talk about today na limit and continuity. Continuity of a function. Limits and continuity of a function. Now, first of all, we go talk wetin limit be. If we get time, we talk about continuity, or we go talk about continuity in another class. Now, wetin be limit? Limit na something wey dey very important when we say we wan learn calculus. Limit na one of the topic dem wey dey very important when we dey learn calculus. And e also dey like something wey you go learn first before you go enter the calculus dem well well. Na so e be, na one pillar when you wan learn calculus. As calculus na something wey dey do how things dey use change with time or with respect to another thing. Now, before I talk about the limit, there are some things wey some terms dem wey we go really wan really talk about. Now, those terms dem na wetin? Before we talk about one of the terms dem, the terms dem, limit na something wey like something dey for somewhere. Now you dey go towards the thing but you no really reach the thing. Na that kind thing. Say you don dey go towards the boundary but you never really enter the boundary. Very very close to the this thing. For mathematics, sometimes we dey use the word like dey say we don approach a particular point. Sometimes we go say we don tend to. All those ones na mathematical grammar wey we dey use when we dey learn limit. Now see wetin I wan write. X. See this arrow. Now see this statement wey I put for here. This one wey we write here means X approaches A. Now see this minus wey dey for up means e dey approach A from the left hand side. Say X. Say this means X approaches A from the left hand side, where we say left hand side. Say this one means say X dey approach A, this point A, but from the left hand side. So for grammar, we fit still say this one na X tends to the point A from the left hand side. These two grammar dem na the same. You say or say X, all the values wey X get wey dey for the left hand side of A, na im be the meaning. Now make I try to draw one line to really explain wetin I dey talk. All the values of x wey dey the left hand side of A, na im be the same grammar wey we dey talk. See wetin I wan write now. If we assume say here na A, this one na the left hand side, this one na the right hand side. So wetin dis statement dey mean say we dey get interest for the value dem wey dey dis side, wey dey very close to A. No be value dem wey dey far far. Those ones wey dey very close. Like those ones wey dey approach A, very very close to A, but e no really reach the A, but very very close. But from the left hand side. Now if we say make our A be equal to 2. If we say make our A be equal to 2, then meaning here will be 2. So this statement here, dey mean 2, because we don say make A be 2. So now, those values dem wey dey very close to 2 from the left, you know say if 2 dey here, the next point maybe you say na 3, you go dey increase dey go. Meaning this side go be 1, here go be 0 dey go. So the values dem wey dey very close from the left na something wey be 1.9 dem. 1.9 dem dey very close. If we wan say we dey very close, you fit say 1.99. If you wan dey close, 1 plus 999, you fit even say 1.9999. The more you dey go, the more you dey check it now, you go see say we dey very close to this point too. So these ones dem na dem be the thing. So we dey say all these values dem wey dey very close to A, but from the left, na im be the meaning of this statement. Now what of if we come say x tends to A, but see wetin we write. The other one na minus dey on top. Now this one na plus dey on top. Now this statement now means, this also means x approaches A from the right hand side. From the right hand side. Or as I talk, you fit say x tends to A from the right hand side. So these statements, as I've been talking for the other one, these statements also means the same. For this one now, you say the right hand side. So now, if we come back to this our diagram here now, and we say make our A be equal to 2. If our A na 2, then we are now saying that all the values of x wey dey close to these points 2, but from the right hand side. Now, wetin be those numbers from the right hand side? You go see say na about, from here now, you go just pass am small, so you go say 2.01. 2 point, if you want dey very very close, 2.001, 2.0001, and so on. You go dey go. Somebody fit say 2.02 first, and go dey go. All these values dem wey dey here na the values dem wey dey On the right hand side, very but very close to, to 2, to the point 2. So these statements the way we dey see here, na statements the way they very, very important. X tends to A from the right, the other one I say X they go towards A from the left. Now what of if we can write similar thing? But this one now we no put plus, we no also put minus. Then wetin we dey talk? Then this one now dey mean say we dey try to consider all the values wey dey in the neighborhood of A, both left and right hand side. When we put plus, those in only one side, right hand side. If we put minus, then you say na left hand side. But when we don't put anything, then we say we are interested in both left and right hand side. So we say in the neighborhood, the surrounding of A, both left and but very close. Those x values they will be very close to that point. Now, this thing where we write here and this other one where we write here, we still write this one as x is equal to A plus h. This one and this one. Now the same thing. Where this h wey dey here, we dey sometimes call them step size. If we write this one like this, that means this other one wey dey here, we fit write them as x is equal to A plus, when this one be A, say A minus h. This one, where I say this h here, na the step size. Now, if we say A na 2, then minus h, those small, small number where you go add, we go make am the 2. Na him be this one. Like this other one now, if you see now, this one now, wetin we comot here now, na 0.1 dey here. So if we add 0.1 now, you go come here. So here na 0.01 na him dey here. Here na 0.001, here na 0.0001, na him be the h wey comot for the A. This other one for the right hand side, wey we add na these ones dem. This one is 0.02, 0.01, 0.001, 0.0001. Now those ones, if we add, it will come give you that set. So wetin we dey talk say, either you write am like this or you write am like this, all of them are the same thing. But where we dey call this one the step size. So this one here now, we dey say we get interest where x dey in the neighborhood of x dey in the neighborhood of A minus h, comma A plus h. X dey takes this value in the neighborhood of that. So now so the thing be. Now make I put some graph, make I draw some diagram wey go help us dey explain this thing wey I don dey try talk. Now, make we consider something like this. Make we consider something like this. Now, make we see this graph where this one now. f of x. Now, before I explain this graph, make I write something as x tends to 0 is equal to what? Now, see statement where I want make. Now, the limits, will they say the limits of a function, say f of x, say na a number where f of x they go to. The limit of f of x na a number, say L, where f of x they go to as x they also go towards a particular number, say C. As this one they go towards this one also they go towards this. Now, make we go back to that diagram. This one a statement we did. Now make we go towards this one. Now we dey say the limit of f of x, which number wey f of x they go to as x they go towards 0. Now make we see, this is the x-axis. So this is the x-axis. So as x they go towards 0, see 0. Now, if you look here now, if you look here now, sign no dey, minus self no dey, plus self no dey. Means, I don't say that one means make you check both left and the right hand side in the neighborhood. Now, if we write the limit of f of x as x tends to 0 from this, as x tends to this, then we say we are only interested in as the left hand side as x is tending towards 0. Now, if we can write the limit of f of x as x tends to 0, but from the right is what? Now, this one is saying that we are only interested in the function as they go towards, as x they go towards 0, waiting the function they go towards. So this one that we have is a combination of all. And when you don't check, this one go towards the same number, this one go towards that same number, all of them get the same, then we say limit exists. Now make we go back to this function, considering this one, because this one now means the 2. So make we check the left hand side. As x they go towards 0 from the left, see 0 here, this point is not 0. So x they go towards 0. As x they go towards 0 from the left, as x they go towards 0. Now, waiting this f of x, they also go. They see say f of x they also go towards a particular number, and that number now 2. From the left, as x they go towards 0, f of x they also go towards 0. So as x they go towards 0 from the left, f of x they go towards 2 here. Now, from the right, let me check this one now. As x they go towards 0 from the right, f of x they go towards waiting. As x they go towards 0 from the right, you see that this f of x also they go towards this point. And that point is still 2. So you see both from the right hand side, f of x, as x they go towards 0 from this side and from this side. The function f of x they also go towards a particular number 2. So we say the limit of this function is equal to 2 as x they go towards 0. So this one now one example we don't learn. Make we consider another one. If you understand this one, for those of you who maybe don't understand that, make I put on that one so that one will maybe help us to understand better. If we consider, say, if we consider this one, where we have this one, make I call this one pi all over 2. Here na pi, here na 0. Then this point, may I call this one 1. This point na 1. This one corresponds to this one. Now, the question now, if f of x na sine x, what is the limit of the function f of x? This one. As x tends to pi all over 2. What is the limit of the function as pi tends to, as x tends to pi over 2? Now, x tending to pi over 2. This one, no minus, no plus, means both from the left and from the right. What is the function? This one we have now, this one now, I the function f of x. Now, if you look there, you see, say, from the left-hand side, as x, they go towards this point here. The function, they go towards that same point. And it corresponds to something, 1. Now, in like manner, from the right-hand side, when x, they go towards this point, when x, they go towards this point from the right, you see, say, f of x self, they go towards this point, and the point where it corresponds to, now also 1. So we are saying that the limit of the function, where the function is sine x, as x tends to pi all over 2, we are saying that this function also they go towards 1. Now in this now we say the limit exists. The limit exists. Even in this case, we say the limit exists. This one, the limit also exists. But in case we find this one they go different side, this one they go different side, then limits no exist. But for these ones, you see, say both from the left hand side, from the right hand side, the function they go toward a particular point. Then we say the limit exists. Then I give one another example. Maybe we see as a day. Make we consider another example. Make we see as a day. Here na -1, here na -2, here na -3, here na -1, -2, -3, here na 1, here na 2, here na 3, here na 1, here na 2, here na 3. Now see wetin I dey try to do. See wetin I dey try to do. A function starts here. Another one 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 starts here. Now, all these first parts, they say is taken, but this one is approaching. You know, really take the particular number very close to it. This one too, it starts, you take the number, but this one very close to it. You start the number very close to it, starting very close to it, and this one too, and so all of them be. Now, the thing where I want to write now What is the function? I mean the limit of the function. The limit of the function as x tends to 2. As x tends to 2. What is the limit of that function as x tends to 2? What is the limit of that function as x tends to 2? Even in this one, you can see that it's also very clear. It's very clear because, first of all, here we are saying that the neighborhood of 2, so both left hand side and right hand side. So here too, and I don't say, na minus self no dey here, plus self no dey here. So we dey say those numbers they will be very close to 2 for the left hand side and from the right hand side. So now make we look the left hand side. X as they go towards 2 from the left hand side. Where 2 dey? See 2 dey here. Now x as they go towards this point, you see say f of x, this one and the f of x. This f of x, you see say they go towards a particular point, and the points correspond to 1 here. As x they go towards 2, this function they also go towards this point, and the point when they go towards correspond with 1. So the left hand side of f of x as x tends to 2 is equal to 1. What of the right hand side as x tends to 2? Now, from the right hand side as x they come towards 2, you see say no be this function here, now this function. As they go towards 2, it corresponds to another thing, and that one now 2. As x they go towards 2 from the right hand side, it corresponds to this function where they also go towards a point, and the point will correspond to that 2. So this one now 2. So in this one now you see say for the left hand side when you check now 1, and for the right hand side when you check now 2. So in this one you say they are not the same. All of them they go towards a particular point. So you say limit doesn't exist. In this one you say limit doesn't exist. Limit does not exist in this one because all of them go their different ways. Now this one wey we do here na graphical explanation. Now maybe we try to consider analytical way so that we will really understand wetin we dey talk. So all the grammar wey we don speak now, we dey say when we say find the limit of the function, e dey mean say na to look for those values dem dey very close to wey dey very close to, I mean wetin f of x dey go to as x also dey towards a particular number. Now make we consider one example. This one I no be graph I go use again. Make I use another way, use right hand so that we go understand wetin we dey talk. Because plenty of our book dem sometimes no be the graph that they use, na this method na dem dey use. Now if we say example, you say find the limits of the function f of x equal to 2x plus 1 as x tends to 2. find the limits of f of x, of the function f of x, as x tends to 2. Now this one means both left and right hand side. We could try am now. Meaning, say, like the way we with the right hand, this statement now, the limit of the function as x tends to 2. Now waiting. Now you be the statement we did there. Now, 2 means the left hand side of 2, we dey talk about 1.9, 1.99, 1.999, and so on. And the right hand side now 2.1, 0.1, 2.001, 2.0001, and so on. This one are the right hand side value. So make we see now, when this one when x take this one, you see the 2 times this one go give you about 3.8 something. 3.8 something. Plus this go give you about 4.8 something. This one will give you 4.8 something. If you do this one will give you 4.9 something. This one will give you, if you do this one will give you 4.99 something. So you see, say, this one now is close to a particular number. This one too, they more closer to the number. This one, they more closer to them. That number is 5. That is where the thing they go towards to. Now, if you carry this one now, put for this one, where x takes this one, you will now see, say, this one will give you 4.02. This one will give you 4.02. This one will give you 4.002. This one will give you 4.0002. So you now see, say, this one, this one, plus 1, plus 1, plus 1. So that this one will give you 5.02. This one will give you 5.002. This one will give you 5.0002. So you see, say, this one, they approach 5. Why this one don't reach the 5, just they pass them small. So you will see, say, all of them, they go towards a particular point. This one, approximately 5, all of them. So we say the limit of this function as x tends to 2, say f of x, they also they go towards 5. Based on what we don't check. So in this one, we say limit exists. Limit exists. In this one, limit exists. Now some people go feel say, wetin make we dey put those numbers dem wey dey very close instead of just putting the number, evaluating it at the point. Now, if you talk like that, sometimes not be so e be. If you put am like that, it go give you wahala. If you check am very close, e no go give you the trouble. But if you put am exactly, sometimes e go give you trouble. Now, make we consider some example wey sometimes if you no look am for the boundary, you can't put am exactly, e go give you trouble. If we say, make we find the limits of the function say f of x is equal to -1 all over x minus 1. As x is not equal to 1 or 10 to 1. Now, let's look at that one. This one now means make x no take 1, no. Because if you take 1, as people they talk now, Or let us say as x tends to, as x tends to 1. Now people say, why we no put the x is equal to 1 direct? If you put x is equal to 1 direct, you go see say 1 minus 1 will be 0, and this place you go make am undefined. That one we no want. But if you check the thing very close to 1, you go see say e no go be like that. And if you check the left hand side of this one, the left hand side now 0.9, 0.999, 0.99999. If you all do all those ones, if you put 0.99, 0.999, you do this thing, it will give you, the answer will give you 2. Not gonna test time. The answer will give you 2. Now, for the other side, now the right hand side will be 1.000. So if you put that on 1.00, you carry this one to put for the same thing, do. The answer you will see that they go towards 2, and limits exist. But if you put evaluate them at that point, x is equal to 1, you go see say the thing go disappear. Now, for those of una wey also get spiritual eyes, una go see say this thing too, you fit write am in another way. How you go use write am? See, first of all, I don say make una consider 0.99, 0.999 on the left hand side. Then on the right hand side, make we consider 1.01, 1.00, 1.001, and 1.0001. If you consider all these ones, you go see say the answer, everything dey boil down to f of x dey go towards 2. F of x dey go towards 2. This one na the left hand side limit. Then this one na the right hand side limit. F of x go go towards 2. Now better still, this thing wey we see here, f of x, wey we get f of x is equal to x squared minus 1 all over x minus 1. This thing can also be written as x plus 1 into x minus 1. Now all over x minus 1. So that this one and this one will go. So that you get only f of x will be equal to x plus 1 only. Now this one now, dey clear as compared to this one. E dey clear because as x dey go towards the left, and 1 towards the left, when you put this one here, you go see say you go get 1.99 approximately 2. So this one will be 1.9999 from the left. Now if you put this one then, the right hand side then here, you go see say you go get 2.01, 2.002. So you go see say f of x from this one now e dey very clear. From this one, it is very clear. Say f of x go to 2 when you consider this thing. So you see, say it is very good. So but e no good to evaluate the thing at the exact point, because if you do like that, it will give you wahala. Make we consider another one again. Make we consider another one again. And this one now, we dey say the function wey we get f of x for this case na sin x all over x. Say make we find the limit as x dey go towards 0, but where x is measured in radians. Where x is measured in radians. Now when you check this one, as they go towards 0 means we are talking about plus or minus the values then, plus or minus 0.01. Plus or minus 0.001, plus or minus 0.0001. These ones there. This one they more closer to 0 than all these ones. Now, when you test these things here, you go see say e go give you, e go go f of x. If you test these ones, then you go see say f of x dey go towards 1. F of x dey go towards 1. But if you evaluate at this point 0, you go see e go make this thing 0. You go make am disappear. So when this thing then give you, you need to look well to make sure say you know wetin you dey do. Make we consider now, so this one too, limit exists. This one wey we don do to limit exists. Now make we look another one. Make we consider another one before I comot for this talk. If we say, make we find another example. If we say find the limits of f of x, where f of x na 1 all over x, as x tends to 0. Now, as x tends to 0 means plus or minus, we get 0.01 plus or minus 0.001 plus or minus 0.0001. Now, when you test all these ones, the minus side na the left-hand side, the plus side na the right-hand side. Now, when you test for that one, you go see say when it be minus, it go give you negative value there. Then when it be plus, you go see say it go give you positive values there. So this one, limit doesn't exist. Limit does not exist. And make you know evaluate at this point. Once you put an here, it will make the system undefined. No be that one will define. But if you consider them in the neighborhood of 0, you go see say that function limit doesn't exist at the point x as x tends to 0. Now that we don't learn this one, make I try to give one definition based on that statement where I will make. When they don't give you the function, they don't give you wetin f of x for you to check whether limits really exist. Make I show you something, make I write one statement so that we go understand wetin I dey try to talk. Now, see the definition of where I want to give for this side. Definition. And they say the limits of a function, say f of x, say now a particular number L that as x they tend to another number, say C. If for any positive number, say epsilon, if for any positive number, say epsilon, say there is some positive number as well, delta, positive number, say delta greater than 0, such that the absolute value of f of x minus L, the absolute value of f of x minus L is less than epsilon for all for 0 less than the absolute value of x minus c, x minus c less than delta, less than delta. Now see the statement we are not make. The limit of a function say is equal to a number that f of x approaches as x also approaches another number, say c. Now this one holds if for any positive number, say epsilon, say there is some positive number also delta that is greater than 0, such that the absolute value of f of x minus this number that f of x approaches, the absolute value is less than epsilon, that positive number, for all 0 less than this, less than this. Now, how to confirm this one now? When you are given the problem for you to confirm, all that you do is to determine the value of delta. All wetin you go do when this kind of thing they don't give you, now to make sure say you find wetin delta be. Once you don't find that one, it don't finish. Now make I give you one example so that we will find delta. Delta we don't lost, make we find it. Delta we don't lost, make we find it. Now, example. I will write some, I will solve some, and I will come solve the other ones then. Now, prove that 1, the limit of a function, say f of x, where f of x is equal to 3x minus 4, say now 14, as x they tend to 6. 2, the limit of a function where the function now 2x minus 1, say now a number 3, as x they tend to 2. 3, the limit of a function where the function now 2 minus 3x is equal to 5, as x they tends to minus 1. 4, the limit of a function, say the function now absolute value of x is equal to absolute value of c, as x tends to c. Then lastly, make I write another one, say 5. Now, f of x is equal to -1 in one case, then 1 in the other case, for x less than 0, and this one for x greater than 0. And maybe we find the limits of, make we show, say, when x approaches this, say this f of x will approach that. This one, when x approaches 2, make this function also approach. Say, make we prove, make we show. Now, based on this definition we will get, wetin I talk, I say, now just for us to find the value of delta. Notice the statement say, this thing happens, that statement we will get, that it happens if for any positive number, say epsilon, okay, there exists some positive number delta, such that the absolute value of f of x minus this is less than this for all this also happen. So maybe we try to go through waiting at the top to really understand how the kingdom look like. Then we use it under, use solve that thing to really see how the kingdom really look like. Now, Make we consider this first one. Now, based on the statement, see the statement though. Delta is greater than 0 such that this one, the absolute value of f of x minus L. So we are saying that the absolute value of f of x, the absolute value of f of x minus L is, f of x is, in this case, f of x, this is f of x, where we have f of x to be 3x minus 4 minus L. What is our L? L is 14 based on this definition. F of x is that where L is 14. We have put this. If you simplify this, you are going to have 3x minus 18. And this you can also write as 3 into x minus 6. And you can bring this one out and you write it as 3, the absolute value of this, x minus 6, where this one is the same thing as just 3, the absolute value of x minus 6. That's what we have. Now, I have tried to simplify this side. But remember that this one that we have talked about has to do with epsilon. Now, for this other side, now look at it, where we say for all 0 less than this, where we have the absolute value of x minus c. Now, this is our c. What is our c here? C here is 6. So this one is equal to the absolute value of x minus 6. But remember that this one has to do with the delta. Where is it? This one is delta. This one is for the epsilon. This one is for the delta. So, but if you look at the one for the epsilon, you are seeing that this part and this part is looking alike. Then you can say that this part can further be written as, 3 into x minus 6 is equal to 3 delta, because this one is for the delta, which is here. And here, the whole of this is epsilon is equal to epsilon. Okay? This one is from here, which has to do with epsilon, the whole of this, while only this part is for the delta. So the delta here is here, but remember that the whole of this is for the epsilon. So 3 delta will be equal to epsilon. So we're going to say the thing now, they very clear now, based on which I don't like. This side now, the side way they do with this epsilon. That side, now the side way they do this part, we did there now, and the part way they do with the delta. So this one combined, now epsilon. So this one delta, 3 of the delta, they give us 1 epsilon. But we don't say for us to really prove that one, now just for us to determine the value of delta. So now to make delta here the subject. So if we make delta here the subject, then we get delta will be equal to 1 all over 3 epsilon. Now, this one now we don't find the delta. So we now go back to our statement. We'll say delta greater than 0 such that this one. So we now say, based on this statement, we now also say delta greater than 0 such that the absolute value of f of x minus L less than epsilon for all 0 less than x minus c less than 1 all over, in place of delta now, we now put that on 1 all over 3 epsilon. So this is our proof. So for us to show this one, to make sure say epsilon dey positive, epsilon also dey positive for all positive number, and in that one it dey clear say epsilon also dey positive. Now based on wetin we don do here now, we fit also try another one to really explain wetin we dey try to talk. Make we consider another example. If we wan consider another example as we do, make I maybe consider say example 2. We don do this one. Now make we do this one, C. Now, based on the statement, we say, for this one, we say, absolute value of f of x minus L is greater than, well, data is such that this. Now, this one will give us f of x in that one is 2x minus 1. That's what we have. Now, this minus L, what is our L? L is equal to 3. If you simplify this one, you are going to have, the absolute value of 2x. This to this will give you minus 4. Now this one where we get, you fit also simplify as we do, as 2x minus 2. Now this part we don't do, now the epsilon side. Now maybe we go to the delta side. Now the delta side say the absolute value, the absolute value of x minus c, that one will be equal to x minus, where c for here, c na 2. So we say 2. Now if you look this one now, this part and this part now resemble well. This whole thing now for epsilon. This part here now just for delta. Meaning say 2 of the delta now they make the epsilon. So we say 2 of 2 into x minus 2 is equal to 2 delta, as we show. Now you make 1 epsilon. So making delta the subject, we say therefore delta will be equal to 1/2 of epsilon. That's what we have. So going back to that our statement based on the definition, we then say for delta greater than 0 such that f of x minus L less than equal to 0 for all this less than equal to 2. That's what we have. So this thing dey pretty simple. Also in this one you can see that epsilon there is positive. Now I want make una do this one by ourselves, also look this one by ourselves. All these ones that they straight away, they like the other one we don't do. But make we look this one, we get somehow this number 5. But for me, the number 5 is even simple pass. But for those people where maybe the way they think they say, I don't understand the number 5. Well, if for do number 5, make we do the number 5. Now the number 5, that one dey simple. We say we get f of x. Now f of x na piecewise function. where one of the function, the two functions are constants, but one of them na -1, where x take a smaller value, the left hand side of 0, where x is less than 0. Then when it be 1, say x dey greater than 0. So greater than 0 means that one dey the right hand side. So this one this is simple. When you consider the left hand side, the answer na -1. That is the limit of the function. The limit of the function. Limit of the function as x approaches 0 from the left hand side, because say x dey less than 0, so the left hand side. Say the answer na -1. While this other side, the limit of the same function as x tends to 0 from the right hand side. This one now na another thing. So this one now, the things they no be the same. So we say limit doesn't exist. So we just go straight away. Say this one no dey exist. All the other ones that we don't confirm, say the limit then exists. These two wey we don't do, the limit exists. But this one, limit no exist. Because the left hand side they give you different number, the right hand side they also give you another number. So with the way that one dey now, it dey pretty simple for us to do the number 3 and number 4. So I would like make una do the number 3 and the number 4. Now, sometimes, now limit o, but dem go say make you evaluate at the point. Now limit o, but dem go say make you try to evaluate at the point. Like this kind of thing. See, if they say evaluate, say the limit of the function, where the function is 5x squared minus 12x plus 2 as x tends to 1. This kind of thing. Make you evaluate at that point. This one now, it dey very straight away. This one, it dey very straight away, sharp. Even if you consider the neighborhood very close to 1 here, the answer will be the same thing. But now make we just put this one straight, because this one now no go give us oroko. Because you no go give us oroko. If you try am, I want make una go try am. But this one now, if I put this one here, I go get 5 1 square minus 12 1 plus 2. This one will give me 5 1 minus 12 1 plus 2. So this one and this one will give me 5 minus 12 plus 2. So these two will give me 7 minus 12. And if you do them, the answer will become minus 5. So if you evaluate at this point, this one and you answer. But I dey tell you now, say make una test the neighborhood, both left hand side and right hand side. You go see say the answer na this one. So things like that dey wey you go test. So based on this knowledge wey I don give una, I believe say una go fit do very well when you don come to this thing dem. Toilet dey go. So as you don reach here, I go like to bam small break. Wetin we don learn here na say na limits and continuity, but we never talk about continuity, we only dey talk about limits. And I don tell am say limit na something wey dey very important when we say we wan learn calculus. Okay? Na something wey dey very important. Na things wey you go learn first so that you go understand wetin calculus really be. And we don say limit na something wey say you dey go towards a particular number, and so the limit dey. You no really dey go to the point, you no really stand on the point, but very close. Na so we talk am. And the way we use write am, we don write some say you go consider them from the left hand side, some from the right hand side. But if all of them na the same number e give you, then we say limit exists. But if na different thing, when you check the left hand side, you check right hand side, na different e give you, then you say limit no exist. And we don also give some definition and we don prove to know whether limit exists or not. Okay, if everything dem give you, now make you find, make sure say limit exists for those things. We don also learn all those ones. So for here, I would like to bam small break. I would like to bam small break so that maybe our next class we go learn wetin continuity also be. Make una thank you and bye for now.